Hey everyone, and welcome to The Explainer. Today we're unlocking something pretty special. The ultimate masterclass blueprint to conquering the highly exclusive CG Trader Wildcat platform. If you've been searching for our consistent, no-bidding freelance stream where you can earn up to $200 for every delivered 3D model, well, you found it. But here's the catch. Getting in, and more importantly, staying in, requires an elite level of technical precision. So before we get to the good stuff, let's start with a dose of brutal reality. The failure rate for new applicants is notoriously high. Just take a look at this real complaint from the Wildcat forums by user Tubasa Art. They call the specifications unrealistic, complaining about the strict polygon counts on pure curves and the texture resolution limits, and ultimately, they just call the whole platform an absolute waste of effort and time. It's a really tough environment, and the QA reviewers, they do not mess around.
So, that begs the question. Is Wildcat actually an impossible standard, or is it just a deeply misunderstood one? Well, the truth is, the standards are entirely achievable, provided you stop treating it like a general art portfolio and start treating it more like mathematical engineering. If you build a very specific type of portfolio, you're going to get in. You'll bypass those automated validators, and you will get paid.
Okay, so here is our roadmap for today. We're going to systematically break down the Wildcat quality standard, exactly what models you need for the ultimate portfolio, how to master those curve-heavy designs, CAD to real-time workflows, PBR materials, and finally, how to defeat the Kodama Validator plugin. Let's kick things off with the Wildcat quality standard. You really have to understand that Wildcat operates as a direct assignment platform for global enterprise clients. We're talking Fortune 500 companies. This means absolute technical standardization is the only thing that matters to them. Evaluators will immediately reject highly organic characters, unstructured scenes, and anything with messy topology. To achieve that enterprise precision they want, you need to show hard surface objects, industrial designs, and perfectly clean edge flow. Which brings us right into building the ultimate portfolio. If you want to guarantee your admission and secure those first-pass project approvals, you need a highly competitive, curated portfolio. The absolute best types of 3D models to present are hard surface objects, curve-heavy furniture, CAD-designed weapons, mechanical parts, and mixed material consumer products. Presenting 3 to 5 high-quality, technically flawless models in these specific categories proves to the QA team that you can handle the exact type of enterprise work they distribute. Now let's zoom in on mastering those curve-heavy designs. Let's talk about the technical details of mastering those curves, because this is notoriously used for the formidable Wildcat entry test assignment, which is often a curved stool model that trips up almost everyone. 45,000. That is your absolute hard limit for polygon counts on complex curve-heavy test assignments. While standard low poly prop should sit somewhere between 1 and 10,000 polygons, 45,000 is the ceiling here. You've got to maintain your silhouette definition without crossing that threshold. But here's the hidden math behind this mesh validation that really separates the amateurs from the professionals. The Wildcat standard enforces a strict 5-edge vertex limit. If a vertex connects to 6 or more edges, it creates a complex pole. And in high-end real-time pipe joins, these poles generate extreme surface tension, pinching artifacts, and highly visible shading errors under dynamic lighting. You have to manually redirect your edge loops to prevent this from happening. Moving right along to CAD to real-time workflows. A massive chunk of the tasks you'll get on Wildcat involves converting solid parametric CAD models like industrial mechanical parts or weapons into game-ready assets. But there is a fundamental disconnect here. Think of CAD models as infinite mathematical curves built for engineering and manufacturing. Game engines just cannot read them natively. Real-time models are their lightweight, optimized origami counterparts, built from quad-dominant polygons. You can't just hit an automated export button. They require manual rebuilding. Because automated triangulation produces totally broken geometry, flipped normals, and overlapping vertices, you have to use specialized tools. You need to be proficient in Blender's Retopo Flow, Maya's Quad Draw, or ZBrush's Zero Mesher to manually draw clean polygonal strips over the CAD reference. Then you execute a high-precision, high-to-low normal map projection to bake those infinite mathematical details right onto your low-poly mesh. Next up, let's talk about PBR and mixed materials. So once your geometry is perfect, we have to conquer the exact texturing pipeline required for mixed material consumer products. The CG Trader quality standard mandates a strict physically based rendering or PBR metalness workflow. This is what guarantees predictable lighting across any engine, whether it's Unreal or Unity. You must supply exactly one texture map for each of the 4 mandatory slots: base color, normal, roughness, and metalness. And you ignore these strict material requirements at your own peril. Failing to assign a material to a geometry object will cause an immediate engine import failure. You must strictly separate transparent and opaque elements into different materials. You also need standardized naming like M_0_0. Furthermore, your UV layout needs a minimum of 80% space utilization and a uniform texel density, typically 1024 pixels per meter. This is completely non-negotiable for the QA team.
All right, it is time to face the final boss, the Kodama validator.
Even if your model looks absolutely perfect, if it fails the automated Kodama Validator plugin, you can't even upload it. Before you run the plugin, you must burn this rule into your memory. Reset all transforms, position and rotation must be precisely 0, and scale must be exactly 100%. The error objects have non-reset transforms is the single most common roadblock that ruins artists' submissions and causes them to flood the forums in sheer frustration. Seriously, center your model.
Here is your step-by-step workflow for the Kodama plugin. First, initialize the session with your Wildcat credentials. Second, configure the PBR workflow to the CGT standard. Third, execute the audits to check for n-gons or 5-edge vertices. Fourth, resolve any red errors immediately because they will hard block your submission. Once those are clear, click Package and Upload. Kodama will seamlessly gather, rename, and zip the model and textures directly to your Wildcat draft page.
So I want to leave you with this final question. Are you ready to build a Wildcat portfolio that defies rejection and commands elite enterprise clients? By focusing heavily on precision, hard surface, and CAD retopologized models, strictly managing your polygons and vertex edges, and mastering the Kodama PBR workflow, you aren't just an artist anymore. You're a technical 3D engineer. Apply this blueprint today and go unlock that consistent freelance income.